the physicist, sound is a physical quantity that can be measured, compared, and quantified. The sound recordist or the sound designer is concerned more with the psychological effect of sound. The audio artist's response to sound is subjective and instinctive, rather than being objective and scientific.
This churns me up, this makes me happy. And I have been having this feeling the day I started off with music. Something like this, like this makes me melancholy. I relate to this. So I have my own preference when I listen to music, and it depends actually on what state of mind I am. And it makes me wonder why I am doing this kind of music that I want to do, or why am I hearing this kind of music that I'm hearing right now. This intrigueness is something which has inspired me for a long, long time.
The right kind of sound is capable of releasing a lot of energy locked in our souls, minds, hearts. And at a very physical level, sound itself is a form of energy. Sound is caused by mechanical vibrations, and hence it is a form of mechanical energy, capable of causing physical displacements. Like all energy, sound energy is measured in joules, and the energy given out per second, that is the power, is measured in watts. However, an ordinary sound does not have the power to move mountains. The energy is rather small, and hence the power of sound is measured in microwatts, 1/1,000,000th of a watt. The loudness of the sound we perceive depends on how energetic the source is and how far away the listener is from the source. As we go farther and farther away from the source of sound, it grows fainter and fainter. This is because the sound spreads out evenly in all directions from the source, and only a small fraction reaches our ears. Suppose a source vibrates with a power of 1 watt. The energy given out by it gets uniformly distributed in a spherical space around the source. The surface area of any sphere is given by the formula 4 pi r squared. At a distance of 1 meter from the source, the area of the hypothetical sphere is 12.56 square meters. This entire area will intercept the 1 watt energy given out by the source. So, energy falling on 1 square meter area of this imaginary sphere will be 0.08 watt, approximately 1/10th of the total energy given out by the source. 0.08 watt per square meter is the intensity of sound heard at a distance of 1 meter from the source. Now suppose the listener moves to a distance of 10 meters from the source. The surface area of the hypothetical sphere at this distance is 1,256 square meters. The energy falling on 1 square meter area or the intensity of sound at this distance, will be reduced 100 times. At a distance of 100 meters, the intensity reduces to 100,000th of the energy given out by the source. So, intensity of the sound reduces inversely as the square of the distance from the source of sound. In other words, intensity follows the inverse square law with distance. The human ear is capable of responding to a wide range of intensities. A barely audible sound has an intensity of 1 microwatt per square meter. A slightly louder sound, like this, is 100 times more powerful. A clapping sound like this would be still 100 times more powerful. A noisy place like a bazaar is yet 100 times more powerful. An aeroplane taking off makes a noise 10,000 times more powerful. And sound that causes pain to the ears is 1,000,000 times more powerful than the fish market. So the human ear is capable of responding to a mind-blowing range of 1,000,000 watts of sound energy, from a microwatt to 1 watt. The human ear has adapted a simple mechanism to adjust to this range. Our ear responds logarithmically to the increased intensity. If the intensity increases 100 times, we hear the sound as twice as loud. If the intensity increases 1,000 times, the perceived loudness increases only 3 times. This is simple logarithmic arithmetic. Suppose I1 is the intensity of the reference sound, with which we are comparing the intensities of other sounds. I2, the intensity of the other sound, is 100 times more than the reference sound. The ratio of the two intensities is 100, and the logarithm of the ratio is 2. If the ratio of the intensities is 1,000, the logarithm of the ratio is 3. For those of us who have healthy, perfectly functioning ears, how does the hearing faculty vary from person to person? Is there any subjectivity in what we hear and how much we hear?
I can imagine a little more, but I don't think I hear more. I don't think that, physically there is a difference between what I can hear and what you can hear or what anybody else can hear. Physically, I think we all hear the same things, but psychologically, we often filter out many things, because, for example, if you go out on the streets today, you wouldn't be so disturbed. But if you were to go out with a mic and record that and play it back over here, you would be extremely disturbed with the kind of sound that's happening. That's because psychologically, even when you're sitting outside in a normal room, you're filtering out so many sounds. You've filtered out the sound of the pump, you've filtered out the sound of the fridge, the fan, everything you've filtered out. You're just hearing what people are telling you. That's a filtering out that we are doing with our brains.
Personally, when I hear something, it makes me think and makes me wonder why is it happening. For example, the sound of a raindrop, that somehow sets me free. Sound of the road, the noise makes me crazy. It's more aberrant behavior that I can relate to. Sound of violin, sound can make you soothe. Distorted sound, heavy sound can give you energy. It can make you act in a more irrational way that you really don't act in normal times. Musicians tend to listen to sounds in this perspective, and actually everybody should do, because it's a very fun thing to do.
If intensity is the objective measurement of sound energy, loudness is the subjective measurement of the human perception of sound. Based on the logarithmic response of the human ear, bell has been fixed as the unit for measuring loudness. When the intensity of one sound is 10 times that of another, the increase in loudness is said to be 1 bell. So the entire response of the human ear, from the faintest of whispers to the loudest of crashes, has a range of 12 bell. Bell is a big unit. A smaller unit, more commonly used for measuring loudness, is decibel. 10 decibels make 1 bell. So a healthy human ear can respond to a range of loudness from 0 decibel to 120 decibels. How much is 1 decibel? If a 10 times increase in intensity corresponds to 1 bell or 10 decibel, how much increase in intensity corresponds to 1 decibel? It is easy to back calculate. It comes to 1.26 times increase in intensity. So, for every 26% increase in intensity, there is a perceived increase in loudness by 1 decibel. The experience of hearing a 90-piece orchestra often encompasses the entire range from 0 decibel to 120 decibels. When a 90-piece orchestra is performing, for the best effects, Some of the rules that may be followed are: keep a gap of 1.7 meters on an average between two musicians. Place brass and woodwind on risers to help them project their sound better. Allow a clear path between the audience and the woodwinds. Do not put one row of noisy instruments in front of another row.
What we watched right now is one of my most favorite concerts in the world. Actually, this is one of the top rated concerts, the Maestro Yanni, live at Acropolis. This concert has a very typicality with the Western classical structure of music that has been there and is still there. The basic fun for this concert is that they have all used acoustic instruments excepting the keyboards and the guitars and the bass guitar. The music has been divided again into the symphony according to the strings, the tube instruments, that is the wind instruments, and the skin instruments. And one important part, as you just saw, was the vocals. The first thing that one should take notice of is that this is a very unified music, very peaceful music. And while designing a sound or doing a mixing for this kind of a sound, you must be very conscious to create and recreate exactly the correct feel that the music has been composed for. If we look at the variations of all the instruments, we have to place the mics according to their sound capability. Usually the double bass is not mic'd if the place is not that big, because double bass has the capability to cover and reach a distance even if 20 violins and a piano and a drum is being plugged. Secondly, the cello again is mic'd from the bottom to give it the very fat sound, because it has that fattening sound, but it also has the melody which the double bass somehow lacks. As we come to the viola is a bit midi part, so it has that fuller part, so it fills the music up. And remember that the music should be looked upon as a circle. It should come back from the bass and end at the treble. So over here is the bass, over here is the cello, over here is the mid, and then ultimately the violin comes in, which is the treble part. And together, if you hear it from a perfect distance and in a very natural acoustics, the sound sounds good.
A full orchestra also encompasses practically the full frequency range of our hearing. The piano has keys representing 5 octaves. This is the frequency of the lowest, and this of the highest. A drum gives out frequencies in this range. And here is the frequency range of a bass guitar or a cello. The sound of a saxophone falls in this range. Beyond 20,000 hertz, our hearing experience ends. It is the world of bats, dogs, and whales. It is the realm of ultrasound waves. But our ears are not equally sensitive to all frequencies. Chandun's hearing test tells us that both his ears are functioning equally well. One draws a graph of frequency versus intensity of the barely audible sound for the corresponding frequency. One gets a curve like this. It is called the threshold of hearing. It is clear from this curve that our ears are most sensitive in the range 1000 Hz to 3000 Hz. Both very high frequencies and very low frequencies have to be much more powerful in order to be barely audible. Sound engineers use the 1 kHz sound to standardize the performance of audio equipment. Because if the 1 kHz sound is reproduced without any distortion, all other sounds will safely be reproduced without distortion or cracking up. As a practical matter, sound experts have adopted the barely audible intensity of 1 kHz as the zero level. This intensity of 1 microwatts per square meter is the intensity corresponding to 0 decibel. Thus, the corresponding decibel levels for the threshold of hearing will be 60 to 70 for the lowest frequencies and touching 80 for the highest audible frequencies. So, the players playing bass instruments have to blow or pluck really hard in order to make an impact. Some other common hearing experiences can also be explained by the threshold of hearing curve. If you're listening to music in your music system and you keep the volume low, you sometimes feel that you are missing out on the richness of the music. This is because at this level of intensity, the low and the high frequencies are being cut off. You can only hear the middle range of frequencies. One can add a family of equal loudness curves to the threshold of hearing. The last of these curves will be that of the threshold of pain. The threshold of pain is more or less horizontal along the 120 decibel line. This means that the intensity level for the threshold of pain is more or less equal for all frequencies. The energy associated with a sound wave is measured in terms of intensity, the energy passing through 1 square meter area in 1 second. Intensity is an objective parameter. The human ear responds logarithmically to the increase in intensity. 100 times increase in intensity corresponds to a doubling of the loudness. Loudness is a subjective parameter. Loudness is measured in bell and decibel. The human ear is not equally sensitive to all frequencies. It is most sensitive in the 1 to 3 kilohertz range. The barely audible intensity for 1 kilohertz is taken as the 0 decibel level of loudness. If 0 decibel is the threshold of hearing, 120 decibels is the threshold of pain. The range of frequencies a healthy human ear can hear ranges from 20 hertz to 20 kilohertz. Beyond that is the realm of dogs and bats.